Alex is with Eagle Engineering and holds a Bachelor of Science in Geodesy and Geomatics Engineering with a focus on cadastral surveying from UNB and a diploma from Geomatics Engineering from COGS, Central Geographic Sciences in Nova Scotia, just 10 kilometers down the road from where I am. Alex has performed numerous survey and reality capture projects across Canada, as well as a founding committee member of GoGeomatics Expo and the GoGeomatics Slam Scan-Off of 2023 and the Can Slam Circuit of 2024. Currently a member of the Reality Capture Network, the Canadian Remote Sensing Society, and XYZ Magazine listed him as 24 of the young geospatial professionals to watch for in 2024. So welcome, Alex. Nice to see you.
Thank you. Good to be back with you again.
And Kenneth is a project manager and geomatics lead at Terra Remote Sensing in British Columbia. He holds a bachelor's degree in geomatics engineering from BCIT and is an RPAS pilot. Remotely piloted aerial systems, I think RPAS, with more than 10 years of industry experience in survey, remote sensing, geodesy, and RPAS applications. He oversees the RPAS program and georeferencing efforts at Terra Remote Sensing. So Kenneth, welcome and nice to see you again.
Thanks, Tim. Very warm welcome.
So gentlemen, I have a few questions put forward. My apologies for not getting them to you earlier, but we will we'll show the audience that we're not too pre-canned on this discussion. So first, what I'd like to do is open it up to each of you to have a little bit of free time. Do you have any news or insights from your industry, government, academia perspective that you'd like to share with the community that either you didn't have a chance in your talk or that you're not sure it's going to come up during our question discussion and that you'd really like to make sure people know about it. So maybe we'll go in the order that I see on the screen here, and first I'll ask Alex, is there any, what's new? Anything?
Yeah, great. Thank you for asking. So the thing I'm most excited about right now is actually a project that we're doing with Eagle Engineering Consulting. We've just covered almost 8,000 kilometers worth of ground in Newfoundland to map out telecommunication network systems there. It was a successful project. It was going to take us, I think it was 3 years to do it the old conventional way. We estimated 3 months for data collection, and then we did it in just over a month.
Wow.
So yeah, it was very successful. And the data, it's an incredible amount of it, but we churned it out. We've churned it, we've processed it, churned it out, and we're sorting through it faster than we anticipated. So yeah, no, things are going wonderfully. Thanks for the opportunity to brag.
Yeah, no, very good. Charles, we heard a great talk earlier today from you and David Belanger. Any additional comment or anything new you want to tell the audience about?
At the top of my head, what I'm thinking of is maybe the different products that are, being put together and disseminated by our organization that I haven't had the time to discuss earlier. So the Canadian Hydrospatial Network, which is a new, the replacement of the former National Hydro network. It can be seen as the replacement of it, and it's mostly relying on LiDAR data. For like 80% of the layers are derived directly from LiDAR, in a similar way than the USGS is doing with the 3D elevation derived hydrography. So I invite people to take a look at this product. It's a really nice new product for which the coverage will increase a lot in future years. That's one example, but also stuff on digital twins as well. So we are, exploring everything related to urban digital twins and putting in place some prototypes that will hopefully leverage the urban point cloud that we have first, and build from that and build some use cases that will help extract even more information from our foundational geospatial data. So yeah, more to come on that in the future years.
Thank you for mentioning about the hydrographic network. I mean, that's something that when we are working with partner organizations, we often will show them how the LiDAR-derived stream network, in our opinion, is far more accurate than the provincially available hydrographic network derived from photogrammetry. And of course, the big difference being in forested areas where the photo interpreter or the stereo operator, really had a hard time tracking that stream system. So that's a great application of LiDAR technology. And will that also mean that you've got various stream orders to the network as well?
Yeah, if I remember correctly, they are following the Staller order, but I'm not really aware of like the details of the model. But as far as coverage, I know they're starting in the Atlantic at first because this is where we have this whole chunk of LiDAR in our national products. This is where the provinces has completed the LiDAR coverage first in the country. So that it's starting from there. And another thing I wanted to mention is the medium resolution DEM that we announced a couple of months ago. So another very good product, which I think will be it's already highly appreciated by users. It can be seen as the replacement of the former Canadian Digital Elevation Model, the former CDEM.
Yep.
So a new national-wide DTM and DSM that's pretty awesome. So another product that you can find on our web pages.
Remind us the resolution of that one again.
It's 30 meters at the moment.
Okay.
Yeah, it's really it could be a bit less coarser than that, but the purpose is really to have something that you can deal with nationwide for nationwide analysis.
Sure.
So yeah.
Well, no, I mean that's a great. I mean, in the province of Nova Scotia here, we had our best data was sort of we could get down to a 20-meter grid, but it had all kinds of artifacts and stereo plotting artifact issues and so forth. So I think that's going to be fantastic. Gavin, you were with us earlier and gave a really interesting talk on how the solar activity was influencing GNSS, and I know you write for GoGeomatics. Is there any additional topics you want to bring up today and discuss? You're muted there, Gavin.
Okay. So a couple of items. This is a LiDAR-centric, event today. So day job related is something that's rather surprised me is, terrestrial photogrammetry. We've all been burned by that in the past. There were things that were not quite ready for prime time. All of a sudden, they're a serious tool. There's the time of flight on a phone, right? Great. You go to map a pump station or a cell, building top cell tower. It can match a scanner at very, very short ranges. But where those systems really struggled was outdoors for, medium site, a surveying site, topographic. Well, we just finished testing on some sites that had previously been scanned with a very large format, very expensive terrestrial scanner. And the handheld, we couldn't tell the difference in precision or quality.
Handheld photogrammetry.
Handheld photogrammetric based tool. So that's exciting on that side. But what I see, my inner geek going, the multi-sensor stack element of this is going to be astounding. The other one, off-duty, you rate for different, tech publications. The GoGeomatics is one of them. About 2 years ago, some survey associations asked me to look into quantum sensing. It's not quantum computing, it's quantum sensing.
Mm-hmm.
And so I spent the last like 18 months visiting labs and geeking out and talking to developers. UNB is doing quantum gravimetry. Dr. Barrett there, go talk to him. It's fascinating.
Hmm.
But the one that caught my mind about this session was the quantum imaging, quantum radar, and quantum LiDAR. For instance, there's a quantum LiDAR that has already been tested for underwater in turbid conditions, the actual LiDAR units under the water
Okay.
in turbid conditions. And to give you an idea of how bizarre it is, the concept that it's not a photon hitting the sensor. You're actually interrogating a entangled photon out at the object you're mapping. So it's kind of mind blowing. It's a real brain melt, but that will, it's not going to replace sensors. It's going to make sensors more sensitive.
Mm.
So anyhow,
What I have watched on quantum computing, 60 Minutes, other things on YouTube, that entanglement still I struggle a little bit with, but Ken, bring us back to the present here. Gavin, that's great. I want to come back to that quantum stuff in a moment, but Ken, what's new with Terra remote sensing and your field?
Yeah, so as you guys mostly know, I'm the RPAS guy for GoGeomatics and all this stuff, and for Terra Remote too. But traditionally, Terra Remote is a large format aerial mapping company. So, from both perspectives here, I'd like to share what's new here. It's very interesting. From the aerial perspective, we've seen sensors getting, more high resolution, a little bit miniaturized. You put more sensors into it, higher definition, colorized point clouds, all that stuff. And then when you move over to the RPAS side of things, you also see the same thing. It's a convergence of high resolution sensors integrated into more RPAS system. You got the JOQ540, you've got the L2, really, really miniaturized things, but also very accurate, also serves whatever needs you need to do, very miniaturized. But I think what's new on the horizon this year for Transport Canada is they're going to release 2 new licensing categories for RPAS, and one of which will allow you to fly BV loss beyond visual line of sight, and the other one will actually allow you to fly UAA, what's this, RPAS up to 150 kilos.
Mm.
So that is essentially those are helicopter systems. So what I'm really excited to see in both spheres here is the convergence of technology. How would they merge, and what use cases would come out from that? That's something that's going to be really exciting on the Canadian frontier.
Does Terra have some of these large drones, these heavier drones?
We're analyzing what's on the market, and
Yeah.
I think it's a step-by-step process where let's see what TC releases out first. Transport Canada release what kind of licensing looks like, where the training, where's the market as well, and what the safety procedures. I think that's very important, and then we can actually invest in getting one, or having a partnership with someone that has one, something like that, right? So
Yes.
yeah, it's something that I've got my eye on for sure.
Yeah, I think it was over the Christmas holiday that there was an announcement made about beyond line of sight, if I recall. It was
Yes.
a little tricky time to since many of us were on holiday, but I remember an announcement, something of that effect. Yeah. Well, great. I have just some other broad questions, really about trends. What do you folks I'm asking you to look at your crystal ball and just tell me what you're seeing in your industry, your area, as far as trends and so Alex, maybe we'll start with you. What are the trends you're seeing in mobile mapping market, and what are the typical deliverables that your customers are asking for? We saw a talk from Zeos today talking about the idea of heavy point clouds, big data, but then the delivery being light attributed shape files.
Exactly.
can you enlighten us a little bit? We didn't really have a talk today on mobile mapping from the
Right.
sessions, so.
Sure, yeah. No, it is very much the same. That they will ask for the point cloud, which is exceptionally heavy, and they'll ask for the images, which are exceptionally heavy. And then yeah, those enriched shape files where we put in all of that information plus the images you can go to get the information that we're reporting back. And it is, yeah, very much that same way. That frustrating bit of, they don't want 3D information, they want 2D information. So I have to remove all the good stuff to give them what they want. Okay.
You'll probably sell it back to them later, maybe.
Well, yeah. So I'm not necessarily complaining, but I definitely have an issue with the value that's being given. And that's it. Like when it comes down to it, the mobile mapping is still very much niche here in Canada. There's only a few, like about a dozen companies I know that are doing it. Anyone that I've talked to has had the similar experience with their clients. And even in the States, I know that they tend to go smaller scale. Their units are comparable to ours. And but they do much smaller units, but they are more 3D when in their mediums.
Mm-hmm. Mm-hmm. So what would you say your clientele are they more municipalities, or you mentioned about Newfoundland utility kind of?
Yeah, so the majority are those large linear infrastructure. So yeah, your typical municipalities and utility infrastructure, whatever that is, communication, water, power, that kind of stuff. And it is just for that fact, we're covering rapid ground really quickly, but we can also pick up those Sorry, I just noticed that, like, how shiny I am. I'm coming off the flu, so I'm not nervous. I'm just struggling to stay alive. Yeah, so it's just covering that amount of ground quickly, but I could counter that statement by saying aerial LiDAR will do it faster. Yeah, okay. The point cloud density goes down per square meter or per square whatever. But the other thing that you gain from that ground coverage that you wouldn't get necessarily from the aerial coverage is the ability to have the AI then read all of the signs that you go by, so that now you've got a full documentation of all of the signs that were there as you drove through. And so now humans are just going through verifying the information that's being delivered, rather than having somebody go on the ground and confirm that, yes, that's a sign, I think. What does it say? How many signs are on it? La, la, la. So, yeah.
I just drove back from Quebec in the last 2 days, and there definitely are sections of the Trans-Canada, I hate to say it, in New Brunswick especially, that are quite rough. I'm just wondering how much of your work is related to the idea of mapping road roughness or potholes and things like that, or is that a market that you folks don't tap into very much?
It's one that's gaining a lot of traction. So road condition assessments are easily done through mobile mapping, because of the fact that we have that HD imagery. We point it directly down at the ground. Our LiDAR cross sections, we can get them small enough that our sampling cross sections for reporting all of those deviations can be exceptionally small, like 10-centimeter cross sections, to give you the profile of the road in that one section. And then we can do that for whatever increments you want all the way through. So historically, a surveyor would look at the worst parts of a road and kind of try to approximate the worst bits. And then optical illusion would, if they can filter it out properly, that's on them. LiDAR, there is none of that. You
Right.
just tell the computer where the worst parts are, and then you work from there, which is amazing. It's nice to be able to have all the answers before you start the work.
Absolutely. I'm going to move now to you, Charles. And
Yeah.
I really agree with your comment there about how Quebec seems to be leading the way with the wide area flood mapping, and I know, just watching RFPs or people bringing them to our attention, there's been quite a bit of river flood map, topobathy LiDAR surveys in Quebec. I haven't really kept up to find out, have they been successful? Have they been, and you guys did a great job of talking about how not every water body in Canada is going to be suitable for bathymetric LiDAR. Two questions I'd like you to ask about. One, I'm kind of interested in how some of those river surveys are going. I know Saskatchewan has done quite a bit as well. How they're making out and hopefully successful. And then secondly, what are some of the technical challenges associated with trying to pull together the national LiDAR collection at the national scale? And I guess it came up in our talk, but also, any comments about artificial intelligence. And I think you guys already sort of answered that during the talk about how you're employing AI or have a team of people that you're working with to look at LiDAR. So I guess I've really thrown three things at you there. Rivers, how that's going, the national strategy, and then any additional comments about AI.
Yeah, these are very good questions. As far as Topobathy LiDAR in Quebec, yeah, it has been one of the technology they've been using to really to collect the bathymetry data for their flood modeling. Really, it's for them. Like I said in my presentation, it's a tool within the toolkit.
Yep.
Some of the rivers went very well, like 75-80% of riverbed coverage, which is awesome.
Yep.
Some rivers have been like I would say a riverbed that was a bit lower than that, but still it can be used and it can be fill in using another like river hydro ball or sonar or these type of technologies. It's providing them a good first riverbed coverage, which like as maximized as possible, and it can be bonified afterwards. I know that New Brunswick as well has started. They posted an RFP a couple of months ago, so I know they've been they're aiming to collect portions of the coasts and some rivers as well, if I'm not mistaken.
Yes.
So we've been helping or supporting these two provinces in those projects, and in fact it's partly co-funded through FIMP as well. So yeah, it's a small family, this it's small world, so we're trying to learn from the experiences from Quebec and then apply those mitigation actions on the RFP and for New Brunswick, for instance. So learning from all of these experiences is key, I think. Yeah, does that answer your question for Topobathy?
Yes, I think so. That's very good. Very good. Yeah. What about the challenges in terms of trying to pull together, the national strategy and all these different LiDAR data sets at the national scale? I mean, you talk about a lot of data. Holy cow, that's a lot of data.
Oh yeah, it is. It is. Well, first I think it would not be feasible as fast as we've been able to do that without our high performance computing environment that we have. So we're leveraging the Government of Canada high performance computing infrastructure to this is where we store, produce, generate everything related to the DMs and the suites of products that's coming from it. So that's helping us a lot because we're talking about thousands of cores and CPUs, and so that had helped us a lot in recent years. And we've gained some experience, and our team has grown especially with FIMP in recent years. So we've been able to press the gas on producing the DEMs and increasing the elevation coverage. So I think it's very good for all the population, to be honest. Our organization is leveraging it, but we know it's really, really popular and used across the country. So I think it's all positive. As far as challenges, for sure, we gathering all of this data, even though we have the national standard, which is CGVD 2013 and NAT 83 CSRS 2010. there are still provinces that are in, you know, epoch 2002 or even CGVD 28. So we have, our system is able to take all of that and to generate everything seamlessly in CGVD 2013. But it's something that we've learned through the years, you know, to build a system that's interoperable, for, you know, to deal with all of these data. So yeah, it's one of the challenge among others.
Yes, yeah, no, great, very interesting. Gavin, back to this quantum lidar. I mean, I remember there a few years ago, you know, Geiger lidar came out, single photon lidar came out, caused quite a stir at GeoWeek, for example, and people wanting to understand what it was about, and I think, you know, for example, the province of Ontario, I believe, is still in the midst of a big single photon lidar acquisition for forest inventory work. You know, where would you put this idea of quantum lidar in the? You mentioned about underwater and in turbid conditions, so I guess this is where the entanglement thing, as opposed to firing a photon, because I do know a little bit about photons and turbidity, and they don't get along well. You're still muted.
They'll invent the auto unmute. So single photon LiDAR is not in the realm of the quantum physics per se. So what it I could give you the 90-second tour of the two basic approaches. You take a laser and you cool an atom, and that slows down all of the subatomic particles, electrons, photons. It slows them down. This is the only time I've ever seen the Kelvin scale used for anything with geomatics.
Okay.
So you've slowed it all down. In that case, they're all so sensitive to their surroundings or other elements that you can do quantum interferometry. You know, an atom is not the nice orbits that we saw in school. You know, no, it's a jittery blob, and the particles act more like waves. So you can actually do interferometry with it. That's where the quantum lidar. But the interferometry is, yeah, you're looking at the wave of like an idler against the actual, you know, one that's in transit, but also the entanglement. Entanglement is where you've got electron or photon here and one here, and they behave the same. They appear to be the same particle. So you can do interferometry with that. Now that's cold atom interferometry. The gravimetry, like at UNB, you can do accelerometers with it, gravity meters. The other one is where you take a laser and you excite an atom, and one of the particles goes farther away from it than the rest of them. Again, that's super sensitive. So magnetometry, you know, the metal detectors we use in surveying, but also there's applications for that in quantum imaging and LiDAR, and you can also do the entangled properties. What's the spin on this one? How's it behaving? So that's where that's going. So this is a whole different, you know, it's a whole different prospect than like shooting photons through water in conventional methods.
Yeah.
And well, I mean, the big beneficiaries are like medical imaging and everything else in industry. Geomatics, they don't even talk about it. The scientists that I interviewed, like at JPL and all that, go, what's geomatics?
Right.
And I go, well, your quantum radar you're building, that could be used for us for, you know, mapping and modeling things. And he goes, oh yeah, it could. So
I understand you're producing a series of articles. Where can we find, where we'll be able to find those and continue to learn more about this?
Yeah, I just submitted it to different publications,
Okay.
and it's I mean, it's 10,000 words. It's a real beast. But yeah, it may be in parts, but the GoGeomatics community will hear about it.
Get a
you know,
link to that somehow.
when it gets linked up. Yep.
Very, very cutting edge. Very cutting edge. Thank you, Ken. I don't know that you saw my introductory keynote this morning, but I talked a little bit about you know, the sort of, I won't call it explosion, but the recent developments with more and more topobathy LiDAR sensors being drone enabled. But again, they're on these fairly larger drones. The green T dot had a unit that could sit on an M300, a Matrice 300 system, but it seemed like they've sort of moved beyond that already and are moving up to a bigger style drone. You already mentioned the two things as far as sort of weight of the drone and the beyond line of sight. Is there other things that are sort of on your radar? And then following that, we have a question from the audience that I'd like to pose to you folks.
I think I could speak about a couple of things here. You know, the RPAS stuff regarding to topo body LiDAR. I think that's really been floated to the mainstream's field of vision here with last year's yellow scan navigator being introduced to the market. I think that's a very, you know, off-the-shelf first iteration system. And I think when I was talking to one of the resellers last year, when just inquiring about it, because we were always interested in being able to provide multiple different kind of surveys and services, which I'll talk about a little bit in a bit, what Terra does, integrating things. So with regards to topo body LiDAR, I think there's always going to be a power issue. So when you're talking about a M300, you know, it maxes out at 2.5 kilos or something around there. And once you put a sensor on there, which is 2.5 kilos, and it's its own power supply, you're averaging what, a 30-minute flight. So now you're saying if you want to draw on the drone's power or something, or you have a bigger power supply, you know, then it's going to increase the weight.
Yeah.
So if you increase the weight, now you have to look for a bigger drone. What's on the market? You go shopping. Now you got this conundrum, right? Do you want to use battery powered? Or do you want to use a hybrid? You want to use complete gas powered? What are the costs involved? What are the power supply units involved? How do you jerry-rig this thing together to be able to buy these things, right? So there are a lot of components involved. And also when you're talking about topo body LiDAR, I think there's multiple things in there as well. Where are you using it just pure infrared? Or are you using blue-green scanner? You know, are you scanning a river, or are you scanning, you know, a turbid river, or are you scanning near shore? Salinity kind of plays into it, and then maybe that's not the best scenario, because you know, there are other shallow marine survey options that are available, like what Terra does. You know, we have a whole marine arm on the site here, where maybe at this point in time, technology hasn't really caught up yet. We are still eyeing it very closely, because it is a developing thing. It's exploded over the last few years, as you mentioned, Tim. But right now, where we see is like the marine stuff, where we can go in low tide, play around with tides, and you know, we survey a certain portion of the marine site scans or sonar, however that works. It's not really my expertise. But the other side of things is that then maybe we come in the airborne LiDAR system with RPAS, with helicopter. And we survey both things, and then now we find a common point to match these two things up. So that's been one of our key strengths we've been developing over the last few years, or actually we celebrated our 25-year anniversary last year. So we've been gearing up towards this point where data fusion, all this stuff, right? And I think early on, I think Alex or Charles, Alex, you touched on aging infrastructure in New Brunswick. And we also see that here at BC, where because it's aging infrastructure, now there's a need for both marine data sets and LiDAR data sets to be merged together. Now you're talking, these are really large data sets. What do we do with them? Maybe our client is a mom and pop shop engineering firm, it's been contracted by a larger firm, you know, they're not going to be able to host these things. So now you're talking about big data sets, high res. Now we want to host these things. So we've developed our own in-house data hosting platform as well, and viewing portal as well. So yeah, there's a lot of trends involved in there in the last few years. It's a very exciting time for LiDAR, you know, in whatever sphere. It's just mushrooming in ways where when I joined DCIT with 09, LiDAR wasn't even like talked about commercially like that, you know. So it's really exciting. Yeah.
Yeah, no, absolutely. We've got a few questions in the Q&A here, and one is a real interesting one, especially I think having a government agency in the panel, end users, our American colleague. What do the panelists think about the rising tensions between Canada and the US? There is a possibility of increased trade restrictions or even a trade war. Given the reliance of the Canadian geospatial sector on cross-border collaboration, equipment imports, and technology exchange, what potential impacts do you foresee on the LiDAR service providers and sensor acquisition, or is this just not the case? Maybe we can go around. Alex, quick comment, and if it's not really that relevant to you, that's fine. We can pass along. We've got another question in the queue.
Well, yeah, I'm sure that Charles is going to have a lot more to say on this than I will, and Gavin as well. But when it comes down to it, yeah, what I think about the rising tensions, I think I can skip that part. But when it comes to the trade restrictions, I don't want to go it alone because I mean we've always been friends and partners, but we don't need them. One thing that has always been said is that the Canadian geospatial professionals know their stuff. We buy most of our equipment from Europe. Some of it comes from the United States, but you know, if we've got to change, then we got to change. Like, unfortunately, we don't want to do any of this. But if they're going to tie our hands behind our backs, we're just going to go with other options. I don't like having my profession and my country threatened. So I'm more than happy to cut ties if he's going to continue.
So do you guys currently do any business in the US or?
We do,
Yeah.
unfortunately. And so like, yeah, we don't want to lose our friends.
Yeah.
But what I do? Apologize for being Canadian?
And Charles, I don't want to put you on the spot here, but you know, I know one of the retaliatory actions that's being considered is to make sure, you know, services that the government needs to acquire, the Canadian government, to make sure to restrict that to being just Canadian companies or non-US, I should say. And what are your thoughts being a government employee? And we realize you know, you may have your hands tied a little bit here, but.
Well, I would maybe just start by saying that my expertise is more on the technical side of things. So I'm less in those you know discussions about the relationship with Canada and US at the moment. I can say that we have a very, very good relationship with people from USGS. They're kind of our counterparts, and we're doing stuff that is very, very similar to what they're doing. And I mean, whether it be for LiDAR, the 3D program, it's very aligned. Even the North American datum, that the new 2022 NatRef, there's discussions on that. There's been discussions for 5 or 7 years now, and it's still ongoing. And even for the hydro network at the transboundary watersheds, I know they're meeting almost monthly with people from USGS. So relationship is really good on the technical side of things. But other than that, I don't think I can go further than that.
Right now, when you guys do up an RFP or help a province do an RFP, there's no restrictions in there currently about must be a Canadian-based firm, I don't think, is there?
No, it can be a US firm as well. Yeah, we're receiving bids from international companies as well.
Yeah. Gavin, you're our our token American on the panel here. Well, you know, what are people? Is anybody paying attention to this in Canada?
Okay.
We're freaking out, you know. So. And if you don't want to comment,
It's not. No, it's not. Not everybody feels that
sure.
any of this is a good thing, and actually, yeah. When populist bluster meets reality, people find out that and then if there's a reaction to it, both parties end up shooting themselves in the foot. But here's a wild card in this whole situation. Now,
Okay.
Canada is, always very mature geospatial. I mean, really mature geospatial, and it blows me away how mature things are, like what y'all are doing in NRCan. And I'm dealing with cobwebs in a lot of agencies here in states. But the wild card in it is the geospatial intelligence, which is where a lot of the high-end technology and development is going on. The U.S. relies on Canadian expertise in that tremendously. A huge chunk of it is from Canada. That's part of the reality that the populist bluster might hit a wall on, at least in the geospatial sector.
No, it's a good point. It's a good point.
Yep.
I should also
Ken, how
point out
about on the
that
West Coast? Do you folks do much work in the States? And what are your thoughts on that question?
Yeah, regarding work in the States, we do have a fairly impactful footprint in the not just Northwest, the Western states, so like Montana, Idaho, Oregon, Washington, Nevada, some of California. I think lately in the Southeast United States as well, the odd project here and there. But I think with regards to that question, I think that's more of a CBC question for me.
Yeah, yeah. We have another question, and I'll just put it out there to any of you. The question is, they'd like to hear our thoughts on satellite-based LiDAR technology, such as NewView, or other similar advances expected in the next few years. And I must admit, I don't think NewView was on my future mission slide, and I'm afraid I don't know much about it. I paid a fair bit of attention to the ICE sat and wanted to try to. I was involved in a project in Dominica, and as Mark described, the low cloud cover being a constant problem, and basically a Canadian LiDAR company was having a heck of a time trying to finish the project. So we looked at ICESat as a possibility of getting satellite-based laser measurements and so forth, but the way the track and the profiling along the track, it wasn't going to work out for us. But does anybody have any comment or any knowledge around the NewView mission?
I can try something on this one.
Great.
Well, for us, it has the potential to be a very exciting technology to use in our strategy, and like if it sees the light of day, and I don't know how many years, but what I understand of that is that it would provide a highly frequent LiDAR coverage of the whole planet a couple of times a year. So that's my understanding of it. So I think for regions, more remote, there's this map that we're always showing in our presentation, with the north and the south being LiDAR and north being satellite imagery. Maybe it's a potential new technology for the in-between, right? It might be something very, very interesting for us to cover the remaining portions of our strategy in future years. Who knows? Maybe. So we're keeping an eye on that, and really we learn as it goes, and we'll see in future years. There's always the matter of licensing that can applies to these type of data. We are at the government of Canada, at least at the moment, really dealing with open data. So every LiDAR that we acquire, and most of the provinces, except one, are acquiring LiDAR that's open, completely open. So what will be the business model with regards to the licensing of this LiDAR data in the future with NewView? We'll see, but it might be something that's a bit not aligned with what we are dealing with typically. So just more questions than answers, but we are looking at this, and hopefully we'll play with the data in a few years.
Yeah, I just was looking at it briefly. So it's a private firm looking to have a constellation of satellite-based LiDARs up there. So thank you very much for the question. Another question. Also, Array Labs is launching a radar-based constellation, creating 3D data as well. So, you know, the commercialization of the space sector is really taking off, and you know, it for me, I find it difficult to keep up with all of that literature as far as what what's coming in the future. But it's something that I'm glad our viewers are and bringing to our attention. Any other comments regarding the space side of things?
Yeah, so this whole revolution of LEO satellites and the low-cost satellites. I gave you an example from 10 years ago. You know, it's sort of the field of dreams. Build it and they will come. When you have the capability in the global data sets or wide area data sets, people find uses. They completely change the way they do things. One example was the agriculture department in Mexico. An outfit, I think it was public-private, put up 120 small sats, and they were getting daily images, not high resolution, but daily images and spectral to the Department of Agriculture for Mexico for that kind of management. So NewView is this great. It's this neat, ambitious, as you were talking about, Charles. You know, sort of it'll be a mid-range LiDAR available anywhere. Who knows what the licensing and cost model is going to be, but there. Many parts of the world are going to be able to have the capabilities that, you know, the some areas had through local consortiums, airborne, you know. So build it and they will come. That's getting that way with GNSS. The LEO satellite systems like Zona Systems, they're building a low Earth orbit positioning system satellite constellation. You got these imaging ones. There's actually several that are LiDAR based aspirationals, and the radar in the INSAR side of the radar. Yeah, we're just going to be flooded with more data, or have more available, and that means better decisions will be made. The price point of getting that will go down because there's going to be a flood of it, and then people are going to find or do applications that just were not practical at all with the existing data sources.
Yeah, no, it's I mean, I presume, I'm curious whether people have said this throughout time. You know, it's an exciting time to be in this industry. Presumably, people have been saying that as things have gone on, but I really feel like it is in the geospatial side. I guess Alex had some technical issues and had to step off and was trying to get back on. And I see our ultimate host, Jonathan, has popped up on the screen. I think we're near the end of our panel discussion, but maybe I'll just allow one more final thoughts from any of the panelists along the area.
Kenneth, did you want to go? I would have maybe something to say. Sure. I think the NewView constellation, the niche that they are aiming for is a bit different than what we are seeing with the higher density airborne LiDAR data that we are seeing we have seen in the last couple of years. you know, 30 or 40 pulses in cities and these type of things. I think this will stay. New View is aiming, if I remember correctly, at something like two pulses per square meter as a basis. So they're not aiming for high density. It will be more in the sense of highly frequent, more frequent data, but with lower pulse density. So it's a bit of the difference
Yeah.
here.
Interesting. Ken, any final thoughts?
Yeah, I think I would like to echo what I said before, the convergence of aerial mapping technology and RPAS mapping technology, you know, with regards to the new BV laws regulations and, you know, pilot licenses regulations with flying drones up to 150 kilos. It's I think there will be a merging of technologies or convergence of technologies there, you know, whether or not we can swap one out to the other, or is it, I don't think it's something where an RPAS will completely replace a helicopter, or a helicopter will replace an RPAS, or like a drone RPAS thing, right? So I think there's going to be a lot of complementary use cases that can come out from these things, and I'll be excited to see what type of use cases that would.
Yeah, no, it's interesting from sort of from the small scale drone up versus the satellite down. It's a real convergence. Gavin, I'll give the last word to you on the panel.
Okay. The R&D that's going into multi-sensor stacks for the autonomous vehicle market and robotics, even though that's going to take longer to get to full autonomy than people think, but the investment in that R&D and what they're coming up with, that will that already is greatly improving what we can do on the geomatics side. So the idea, and then using the different sensors to stabilize improve the quality and remove outliers of the other sensors. We're already seeing that on mobile mapping systems. Like one that was really impressive was like the Leica TRK. You know, you could put the big gigantic terrestrial scanners on it, but the SLAM on it is used mainly for SLAM stabilization, along with the IMU. So multi-sensor stacks, that's actually, I got asked, that's the next one I got to research. So
Okay. Well, we look forward to next year.